integrate from 0 to 3, x squared dx, which is 1/3 x to the third from 0 to 3. 3 to the third is 27 thirds, which is 9 feet squared. No pi in this one. It's not a circle. Don't try to pull a pi out of front that's not
I know,
there.
at first I was gonna.
I even wrote that in my notes, no pi exclamation, because I was like, I bet they're going to try to put a pi out front or something. You know, it all depends on what the area of your little shape that you cut out is. Or the, yeah.
I still
Is
can't.
that right? Can't picture that? That's why I wanted the SolidWorks. Because I was going to take it and like show you that if you cut it and turn it to the side, it'd be a square.
I could see like the square there.
I could only see it at the base. The rest is
Yeah,
see,
like,
I mean, if you take it anywhere throughout the whole thing,
It's just going to get a smaller and smaller.
keep in mind that's a pyramid, so all of the
I
sides
guess
are
it just
going
looks
in
more like a chocolate.
to the point.
Wouldn't the square be like slanted though?
So think about like the pyramids in Egypt.
Yeah, think about a pyramid in Egypt, what they look like.
Just like
Flat bottom,
just
and
cut
they
it
all go up to
off.
a middle point in the center. So if you just chop the top off,
It's a square.
you got a square. Chop it at any point, and there's a square.
Okay.
Well, I know.
Infinitely thin. You're not,
Good job, Zach.
I mean,
That
just
was
really, really
good.
thin. Just,
I know. I'm a boss.
That was good.
yeah, he gets 10s out of 9s now on quizzes. Do you
I
notice?
just don't do my homework.
Okay, a couple more examples here. Because I got to show you how to do what your homework ones are.
So they're not like
So look at homework.
I know.
Yeah, it's the same ideas, but they word them weird, and you got to be able to look at it. Let's look at number 1. We're gonna do number 1 together.
Number one from like that.
8.3, number 1. Yeah, we just got to get used to the way the book words things and draws
Why
things.
can't they just be simple?
It says, find a formula for the area of the cross sections of the solids that are perpendicular to the x-axis.
Wait, what number are they? Number 1?
So we're not actually going to integrate, we're just going to set these up. That's the hard part.
What the?
Formula for the area of the cross, when it says cross sections of the solids that are perpendicular to the x-axis, it's like this. This was perpendicular to the x-axis. If I chop it up, I get my squares. Our cylinder, we laid across, it was perpendicular to the x-axis.
But this one doesn't.
It's just.
So, number 1, it says the solid lies between planes perpendicular to the x-axis at x equals -1 and 1. So planes perpendicular to the x-axis, here's my x and y, at -1 and 1. That just means there's 2 planes here, so all my solid is between these 2 planes. So the lighting is messing it up. It'll fit between my hands here, right? Those planes are perpendicular,
Got it.
so my solid is in between those. Alright. The cross sections are perpendicular to the x-axis, as we've been doing. These planes run from the semicircle y equals -√1 minus x squared. So if you graph that y equals -√1 minus, I'm going to redraw this because with those not being evenly spaced, it's going to bug me. And it's going to look ugly. So here's -1. Here's 1. The graph of that first equation is just this. Oops. That's y equals -√1 minus x squared. And then the top, that's a little off. Y equals the √1 minus x squared. In other words, it's a circle. And the equation is, of a circle, it would be x squared plus y squared equals 1. Right? A circle with the center at 0, 0 with a radius of 1. Remember that? X minus h squared plus y minus k squared equals r squared. They've just broken it down into graphing. Like, if you solve for y here, you get positive square root of 1 minus x squared and negative square root of 1 minus x squared, right? Okay. And where it says your solid lies between planes perpendicular to the x-axis, meaning I put my hands there and now I've got a ball, a sphere, between -1 and 1. So my picture's not 3D. So it says the cross sections are circular discs with diameters in the xy plane. So if this was a sphere, circular sphere. So if I slice it up, I have circular disks. Write the equation for how you would find the volume of that. That's 1A. And they've kind of drawn you a better 3D picture. So if this was a sphere here, so that means when you cut it, you get circles. You see the picture, number 1?
Oh,
A.
I get it.
The red lines are
The red lines
So
are
for-
cuts.
Yeah, the red lines are the cuts.
There you go, okay.
So what's the volume if the red lines, if they're circles?
They gave us 3 things, I don't know if they
Okay. So what is, this one might be a little harder.
Minus pi x squared.
What is, if we cut these out, our area, it's a circle, so it's pi r squared, right?
Yeah.
But we need to know what is the radius of each one of our circles. So if I'm looking at my picture here, what is, keep in mind my circles they're cut this way, right?
Yeah.
So if I'm looking at it this way, and here's my circles, what is the radius of one of my circles?
It's
Y.
Isn't it this distance from
It's
here to
y
here?
Squared. Oh, the radius, yeah.
Isn't that the radius?
Yeah.
Everyone see that?
Yeah.
So what is the length of that?
Y.
Well, yeah,
Square
it's
root of
y.
minus x
Depending on where I'm at, if I'm at here, it's 1, right? Doesn't it depend on this equation?
Yeah.
So what is my radius?
1 minus x.
The square root of 1 minus x squared. Because it varies with x, right? So what is the area of each circle? Pi times the square root of 1 minus x squared squared. Now do you see how this is going to get harder?
Yes.
And you have
It'll get harder real
pi
fast.
minus pi x squared, because square would go away.
Yeah. So we're going to integrate from -1 to 1. If I simplify this, it's pi times 1 minus x squared, right? But we can pull the pi out front. So really pi from -1 to 1 of
Wait,
1 minus
why'd you
x
square
squared
root the-
dx. I squared it.
Yeah.
So if you integrated that, you would get your volume.
That's what they want, is us to write that, they don't want us to do it?
Yeah, because we're not practicing intervals here, we're just practicing getting that. A little later, we'll actually have to find the volume, but on these, we're just trying to set it up.
Oh,
So in B, now it's not a sphere anymore. Now it says the cross sections are squares with,
this is all number 1?
yeah. Now it says the cross sections are squares with bases in the xy plane. That's really hard to draw, and it's really hard to even picture what that would look like. It would be it wouldn't be a ball anymore. Don't picture a ball. The bottom would be a circle, and then you'd have like squares, and then the top would be this funky. Like I said, if I get some time, I'll try to actually draw what it would look like. But basically, who cares what it would look like? If we take each cutout, it's a square, right?
Yeah.
So what's the area of a square?
X squared.
X squared.
Well, it depends on what's
Sides.
each sides. So look on there.
X squared plus y squared.
What is the length of one of the sides? I mean, the way they've got it drawn, here's y, x, here's my 1, -1.
So the length of the side is that the square root of
So
1
here's
minus x
one of my squares, right? Here's the length of one of the sides of my squares, right? Because these squares come up out of the paper.
Yeah.
So I have to find the length of this side.
Square root of 1 minus x squared.
The square root of 1 minus x squared is the distance from here to
Oh.
here.
So what would be the I
So y.
So can we just do 2 times the square root of 1 minus x squared?
Yeah.
You see that?
Yeah.
Isn't that? Or you could do square root of 1 minus x squared minus negative square root of 1 minus x squared. Either way, isn't the length of this side 2 times the square root of 1 minus x squared? Do you see that?
Square again?
Huh?
a square?
Yeah, the cross sections are squares. So like they're coming out of the paper as. Oops. So I'm just trying to find the length of one of the sides. Well, I know that's square root of x squared, 1 minus x squared. So I have two of them for one of the sides. So how do I find the area of my square? It's this squared, isn't it? So my area of the square is 2 times the square root of 1 minus x squared squared. So now can you set up and simplify your integral a little bit? Don't actually solve it, just. Did you get that? Either 4 minus 4x squared or 4 times that, or you can pull the 4 out front. Either way. All right, because if you square that, it's 4, and the square root goes away. You all with me? Which part are you humming about? Squaring this?
No, I understand.
You got it? Okay. Okay, try C. See if I can do less. Now the squares, now the cross sections. It says, you have to read it carefully. It says the cross sections are squares with diagonals in the xy plane. So that means, here's your xy plane. Now the diagonal of the square lies along there. Yeah, that sucks. So now, nope, you don't need Pythagorean theorem. Now you still are using this length, but now your squares come up out of the paper. Before, well, they did before, but that was the base of the square, and then it
That was
came
the
up
point.
and went across. Now it's the point, so that's like the center of the square. So if you're thinking about your square,
It's like it's the center like a diamond.
that is that right there. Oops. So now how are you going to figure out the length of that? Isn't this length the same as this length? Figuring out the area is going to be different. We need to know the sides of each of the square, right? But can we figure out the length here? What is this length?
I'm really bad at this drawing
It's
stuff.
just the square root of square root of 1 minus x squared.
2 times it though, right? There's 2 of them?
Yeah.
So that length is 2 times the square root of 1 minus x squared. Well, then if you remember your good old geometry days, you know that if you...
Pause it. I mean, restart it.
Oh, yeah. Yeah, it's a bad place to pause. Oh, that's a good place now, because you've created a good place.